Imagine this. It's the year 2035. A record heat wave sweeps across 3 continents, the United States, Europe, and India. Air conditioners roar to life. Electric cars plug in. Factories run overtime to keep up with demand. And then, the grid collapses. Blackouts ripple across entire nations. Planes are grounded. Hospitals scramble for backup. Billions sit in darkness. This isn't science fiction. It's a glimpse into a future where demand for electricity has grown faster than our systems can handle. Here's the reality: as of today, fossil fuels still provide nearly 80% of the world's energy. Yet global electricity demand is projected to double by 2050. That means we will need not just more power, but cleaner, smarter, and more reliable power than ever before. Energy is not just about electricity. It is the hidden lifeline of civilization. It decides which countries rise and which collapse. And in the 21st century, the great battle is, who will power the future, solar, nuclear, or AI-managed grids? Energy is the currency of civilization. To understand the future, we need to first understand what energy really is. Energy is not just a utility bill or a power line. It is the oxygen of modern life. If you cut off energy for 24 hours, society unravels. Airports shut down. Hospitals lose patients. Food supply chains stop. The internet goes dark. We saw a small taste of this in Texas in 2021. A winter storm froze power plants, plunging millions into darkness. Water pipes burst. Supermarkets emptied. Hundreds died in their own homes. That was just one state, for a few days. Now scale that worldwide. This is why every empire in history was defined not by its armies, but by its fuel. A 200-year story of fuels. Let's trace the story of energy over the last 2 centuries. Pre-1800s, civilizations depended on wood, charcoal, and animal labor. Progress was painfully slow because energy was scarce. 1800s, coal arrived. It powered the Industrial Revolution. Coal drove steam engines, steel production, and railroads. Britain's empire was literally built on coal. 1900s, oil took over. It fueled cars, planes, and the globalization boom. 2 world wars were decided as much by oil as by armies. Control over Middle Eastern oil made the US the world's superpower. 2000s, natural gas became the bridge fuel, cleaner than coal, more flexible. And finally, renewables like wind and solar entered the game. The lesson is simple: every great power in history rose on the energy source it controlled. And every empire that lost its fuel dominance eventually fell. Now, as we enter the 21st century, the battle for the next dominant energy source has already begun. The triple energy crisis. The world today faces a 3-sided energy crisis. First, exploding demand. Urbanization, AI data centers, billions of electric cars, all need power. By 2050, the demand is equivalent to adding an entire new Japan's worth of electricity consumption every year. Second, climate destruction. Energy is the source of 75% of global greenhouse gas emissions. Without cleaner power, there is no path to stop global warming. Every year of delay costs trillions in damages from floods, fires, and storms. Third, geopolitical fragility. Fossil fuels are finite and unevenly distributed. Europe learned this in 2022 when Russia shut off pipelines. Gas prices spiked tenfold, factories froze, and entire economies were shaken by a war thousands of miles away. This is the battlefield. The question is no longer whether we transition, but how fast, and with what. Solar, the sun revolution. The sun is humanity's oldest energy source. And today, it is becoming our most promising. Every hour, the sun delivers more energy to Earth than all of humanity uses in a year. Solar has become the cheapest form of new electricity in most countries. India's Bhadla solar park covers 14,000 acres. China is covering deserts with panels visible from space. The US is installing millions of rooftop systems. Solar looks unstoppable. But it has shadows. The sun doesn't shine 24. Clouds, weather, and seasons make it unreliable. Storage in batteries is still expensive, and relies on lithium and cobalt, minerals concentrated in just a few countries. Large solar farms also compete for land that could be used for food or housing. So solar can be a giant piece of the puzzle, but it cannot work alone. Without massive storage systems and AI grids to manage variability, solar energy could remain a daytime-only dream. Nuclear, the hero we fear. One uranium pellet, the size of your fingertip, produces as much energy as a ton of coal. Nuclear power is dense, reliable, and produces zero carbon emissions. Countries like France already run 70% of their electricity from nuclear. The US still has 92 reactors. China is planning 150 new reactors by 2050, more than the rest of the world combined. Yet nuclear carries fear. Disasters like Chernobyl and Fukushima live in public memory. People imagine radiation spreading silently, killing for decades. But here's the paradox: coal pollution kills millions every year quietly, while nuclear deaths in history remain in the thousands. Nuclear is far safer than the fear suggests. And now a new generation of small modular reactors (SMRs) is emerging, smaller, factory-built, safer, and cheaper. The irony of our age is this: humanity fears the very power source that might be essential to save it. AI-managed grids, the invisible brain. Electricity is like water in pipes. The problem? You can't easily store it. Supply and demand must match every second. If they don't, the grid collapses. Enter AI-managed smart grids. AI can predict demand, reroute power, and prevent blackouts in real time. Google's DeepMind already cut 40% of energy waste in its data centers. In Spain, AI prevented a factory blackout by rerouting electricity instantly. In the near future, your fridge, EV, and washing machine will talk to the grid. They will decide when to consume energy based on price and availability. Invisible negotiations happening billions of times per second. The future isn't just about new fuels. It's about the intelligence that manages them. Fusion, the energy of the stars. Fusion is the holy grail. Instead of splitting atoms, it fuses them, the same process that powers the sun. The dream: unlimited, safe, clean energy with no radioactive waste. Projects like ITER in France, US startups, and private firms backed by Microsoft are racing to achieve it. Private funding has jumped from $2 billion to nearly $10 billion in just a few years. One study suggests fusion could cut global CO2 emissions by 75% if it becomes commercially viable by mid-century. But fusion has always been 30 years away. For decades, it has been just out of reach. The question is whether humanity can finally break that cycle, or whether fusion remains forever the power of tomorrow. The 100-year hybrid outlook. So what does the future really look like? By 2100, the most realistic mix is not one fuel dominating, but many working together. 50% solar plus storage, decentralized, cheap, infinite. 25% nuclear, including SMRs, reliable baseload. 15% fusion, if breakthroughs come after 2050. 10% other sources, hydro, wind, hydrogen, biofuels. And binding it all together, AI-powered smart grids that act as the invisible brain of civilization. This isn't utopia. It's the path already visible in today's investments, policies, and technologies. Who controls the switch? So the question isn't just whether solar beats nuclear, or whether fusion arrives. The real question is, who controls the switch? Will it be governments protecting their national interests? Tech giants like Google, Microsoft, and Tesla, managing grids with AI? Or international alliances that treat energy as a shared human right? Because the future of energy is not just about electricity. It's about power itself, political power, economic power, and the power to decide humanity's fate. Truth is not hidden, it's overlooked. Through TrueLens, we bring it back into focus. Because when you see clearly, you live differently. This is TrueLens, see beyond the noise.